Exercise 7.1 Application of Differential Calculus, Unit number 7 is a new unit. We are going to start the new unit today. So, before starting this, we need to know the differentiation. The differentiate is very important. I am going to teach you the few differentiate only. First, I am going to teach you the algebraic one. D by dx x power n. D by dx x power n is nothing but d by dx x power n is nothing but nx power of n minus 1. Nx power of n minus 1. This is an important formula. X power n. For example, d by dx, I am going to differentiate x square with respect to x. This differentiate you were studied in 11th standard itself. D of dx of x square. Differentiate. D stands for differentiate of x square with respect to x. Nothing but x square differentiate is nothing but, see, this is nothing but n. So 2x n minus 1. 2 minus 1 is nothing but 2x. 2 minus 1 is 1, nothing but 2x. This is a differentiate. In spite of doing this formula, I can usually teach you one thing. Differentiate of x cube, we can write, bring down the power down and decrease the power. Bring down the power down and decrease the power, 3x square. Bring down the power and decrease the power, 3x square. If you are going to present d by dx 4x power 4. This 4 is constant, right, as it is. X power 4, bring down the power, 4x, decrease the power, 4x cube, nothing but 16x cube. D by dx 4 plus x power 4, 4 plus x power 4. If this is not in multiplication, this is one term, this is one term. Differentiate of 4 is 0. Bring down a 4 and decrease the power, 4x cube. You can write like this. Therefore, differentiating constant is 0. If it is multiplication, we want to put as a constant as it is. So, this is a differentiate of algebraic one. If a differentiate of d by dx, if we are going to differentiate sin x, differentiate of d by dx sin x is nothing but cos x. This is very important. Differentiate of cos x. Differentiate of cos x is nothing going to be minus sin x. Therefore, differentiate of sin x is cos x minus sin x. If you see move towards few, we can do some other differentiate also. But you want to learn one thing. Here is x, here x. Like this should be present. For example, differentiate d by dx in sin theta. This is very important. See, differentiating sin theta with respect to x. So first differentiate. What is sin theta? Sin differentiate nothing but cos theta. I differentiate only for sin. Next theta is present. For d theta by dx, you need to put d theta by dx. This is some different one. Because here x, here theta, no. So differentiate of d by dx sin t. You can take sin t also. Differentiate of sin t is nothing but cos t. After t is nothing but dt by dx. dt by dx. If we are going to see x, we don't need to put anyway, because x differentiate is 1. But here d theta by dx, t dt by dx. So these are very important things you need to learn from here. So next, I am going to teach you some formulas, which is an average velocity, instantaneous velocity, and acceleration, the rate of change. If the word is coming like this, first I am going to find the average velocity. This average velocity formula is nothing but s of b minus s of a by b minus a. Nothing but s of b minus s of a divided by b minus a. This is the formula. S of b minus s of a divided by b minus a. This is the formula you need to learn here. So nothing but this will be highest one, this will be smallest one, b minus a, because b minus a, b should be biggest one and a should be smallest one, because differentiate. This is the average velocity. First you need to know. Next, instantaneous velocity. Instantaneous velocity. The instantaneous velocity. First, in word velocity means, this word velocity means we need to differentiate with respect to t. That's all. The word velocity tells differentiate. That's all. Not only t, you can differentiate x also. What the variable gives? For example, they given s of t. S of t is equal to t square plus t plus 1. This is given in t. So differentiate. In order to get, this is the distance. You can simply say the s of t is nothing but distance. This s of t we can say distance or length, whatever again. For example, when I say not correct one, but if I want to find the velocity, nothing but differentiate. Differentiate is nothing but s of t. This s of t differentiate will becomes s dash of t. This s dash of t is nothing but instantaneous velocity or velocity. Velocity means differentiate. Once this one differentiate once, this is called velocity. This velocity differentiate once. This will be acceleration. See very carefully what I am doing here. If I going to take s of t is nothing but t square plus 4t plus 1. If I am going to differentiate this one, I get the velocity. If velocity going to differentiate, velocity I am going to differentiate, I will get acceleration. In other words, I can say differentiate this in 2 times. Differentiate this one in 2 times, I will get acceleration. This also easy only. This is also correct word only. If I going to differentiate this one, I get velocity. Velocity difference once, I will get acceleration. Differentiate this one gives velocity. Velocity once a difference, I get acceleration. Otherwise, twice the difference will get acceleration. That's all. This is the same thing. We don't know. I want to say another thing. Rate. Once the rate gives us rate or increase rate. This word comes means I need to differentiate. This is nothing but differentiate. D. Suppose increase in height. Suppose a word comes increase. This is all you want to know. Very thing. Increase in height. If the question comes in increase in height, increase comes means dh by dt. Height no. Height means dh by. Suppose in rate of change of temperature. Rate of change of temperature. The word rate of change of temperature comes rate no. You want to put dt because temperature dt by time. This is time. T stands for time, and height stands for H stands for height and T stands for time. Here caps T stands for temperature and small t stands for time. So the word rate or increase came. I want to make a differentiation. Sometimes they will not give what is the rate water. They will simply say 3 meter cube per minute. When the meter cube comes when this one comes meter cube per minute, meter cube when comes when volume occurs. So I want to write dV by dt. This is nothing but the 3 meter cube per minute. See dV. This V stands for volume. This minute stands for time. dV by dt. Meter cube is something volume. Suppose 5 meter square per second. 5 meter per square. So this can be area. Squares. This can be area. So dA by dt. I want to take it as it is. dA. They will give rate of volume. They give the word rate of volume. They give rate of area. Sometimes in spite of rate, they will increase in area or increase in volume. Sometimes increase in volume. Listen carefully. Increase in volume, increase in area, rate of area or rate of volume or change of volume. Sometimes they given change also. So listen carefully. Rate of area, increase in area, rate of volume, increase in volume. So you want to put dA by dt is nothing but 5 meter per second, 5 meter square per second. This is very, very must. 5 meter square per rate area. Suppose, see, this is volume, this is area. Sometimes they give an answer as 10 meter per seconds. This can be height, this can be length, because meter no. When the meter comes, height, length, or radius, length, breadth. These times all we can scan meter per second. Meter. Square means area. Cube means volume. Only meter is nothing but. In spite of meter, they have given feet also. 10 feet per second. It can be height, distance, length, or like this one. So this all you want to know. These are very, very important terms you need to learn before you enter inside a sum. Otherwise, you can't able to do any of these sums. This exercise this exercise, not exercise, this unit is very, very biggest unit. If you can't know the differential, you can't able to do any sums. But each and every sums before differentiation, I will put formula for you and I will make you to understand. So better listen carefully and go through the all sums.